Hello, I'm Mensa Augustine. In this lesson, we're looking at definite integral as the limit of a sum. So join me as we go through this example step by step to improve your understanding. Thanks to Nityananda Berry from Dugapur, West Bengal, India, for explaining this to me the first time that I saw this type of limits. So Nityananda Berry, thumbs up. Now, let's see how we do this in a very simple way. Now, we have the limit as n approaches infinity of 1 power m plus 2 power m plus 3 power m plus up to n power m, all divided by n power m plus 1, where m is greater than 1. How do we find the limits as n approaches infinity? Let's see how we do this. Kindly follow me on my Facebook page and also subscribe to my YouTube channel for us to build the mathematics community. Remember to leave your comments and like the video as well. So let's see. From here, we're going to write this one as the limit as n approaches infinity. 1 power m plus 2 power m plus 3 power m plus up to n power m, all divided by n power m times n power 1, but n power 1 is n. Now from here, we can factorize this n out. That is 1 on n. So we can write this one as times 1 on n. So if we multiply here, 1 will multiply everything at the top and n will come and multiply. Wow. Now, if I have, let's say, 2 squared plus 3 squared divided by 5 squared, the same as 2 on 5 plus 3 squared on 5 squared. So this is the same as 2 on 5 all squared plus 3 on 5 all squared. So from here, we can write this one as the limit as n approaches infinity, 1 on n times 1 on n power m plus 2 on n power m plus 3 on n power m. Wow, this is power m. Plus up to n on n power m in a very simple way. Now, from here, we've gotten a sequence of partial sum here. So we write this as summation, right? Okay, so we take this as the limit as n approaches infinity, 1 on n. Then we take a summation r equals 1 up to infinity. Then we have r divided by n in a very simple way. So this represents r divided by n, but we have to the power m. So from here, we're going to say that this is the same as the limit as h approaches 0, h times summation r equal to 1 up to n rh power m. So here we take that when 1 on n equals h. 1 on n equals h, or we have nh equals 1 in a very simple way. And as n approaches infinity when h equals 0, see that as n approaches infinity, 1 over a large number will give h to be 0. So that's why we have what we have here. Okay, so from here, we're going to have h to be our dx and rh to be our x. So let's see how we do that. So this is going to give us the integral from 0 up to 1. rh is x, then we have power m. Then h becomes dx in a very simple way. Wow. I said that the first time that I saw this question is Nityananda Berry. That's an Indian name. So I don't know how to pronounce it, but By the way, I think I've done the pronunciation a bit well. Nitnyanda Berry from Dugapur, West Bengal, India, who gave me a brief idea about this, and now I can solve a series of these problems with no mistakes. So let's go with this. So now we integrate this definite integral. So here, this becomes x power m plus 1 divided by m plus 1, and we bring the limit from 0 to 1. Now, if I put in 1 for x, what am I going to get? If I put in 1 here, what do we get? Let's see. If I put in 1 here, I'm going to get 1 power m plus 1 divided by m. Oh, I'm going to get 1 power m plus 1 divided by m plus 1 minus, if I put in 0, I have 0 power m plus 1 divided by m plus 1. So this will be 0 and this will be 1 divided by m plus 1 in a very simple way. So the limit of this as n approaches infinity is simply equals 1 divided by m plus 1. Thank you for watching. Please like, share, subscribe, and leave your comments.